In this episode, Sasha and Keoni use the Pythagorean theorem and the definition of a parabola to derive the equation for a parabola with an unknown distance p from the vertex to the focus and a vertex at 9, 13.
I want you to use the same techniques you've been using with the Pythagorean theorem.
Okay.
But you're going to be working with some letters now instead of numbers only.
So we'll just choose any point.
Mm-hmm. And what's that point called?
This point is x, y.
All right.
And then here's our line. Okay.
So we have...
Oh, so we know that this is our x minus the distance from here to here, which is 9. So that's x minus 9.
And then we have this distance, and we know that's going to be the same as that distance. So we have to have it be, we know up to, where is it, to here is 13, and you're going to add on whatever that is.
2p. Right? Because p's here and then p's here too.
Okay.
Oh, wait, no. P's here and p's here.
So it's going to be... Are you writing?
Oh, my bad.
Gosh. We're going to have it be y. So this whole thing is y, so you're going to subtract this part of it, which is 13, right? So y minus 13. Right?
Yeah.
We can't even see our vertex anymore.
Okay. you tell me what distance you're trying to find.
The distance from here to here.
What is
Our
y?
point to our directrix.
That's not your directrix. That's your vertex
Oh, wait.
line.
That's our p.
Oh.
Here.
So that's what we messed up. There we go. Okay, that makes... I mean, it makes
Does
it
that make
harder.
sense? You're trying to go all the way.
Okay.
You're finding the distance from the point xy
To the directrix, not to that
directrix.
line, yeah.
Right. So what do you have to subtract from the y?
So we're subtracting.
If you subtracted the 13, that would
13
get you up
minus
too
p.
high, right?
Yeah.
So we're subtracting 13 and p.
Well, let's try this. If you subtracted the 13, you'd get up too far, right? What would you
Yeah.
have to add back in?
Oh, plus p.
That's one way to see it.
Okay.
Show me where those pieces come from. Like, where's the y,
Okay,
distance y?
So the distance y is right here.
Okay.
And so if we subtract 13, then we'll be at the line that our vertex is on. So we have to add in our p.
That little bit,
So we
yeah.
get to our directrix.
God.
One way to do it.
You're so cool. Look at you go.
Sasha and Keoni first identified a general point, x, y, on the parabola and a right triangle. They quickly found the length of the horizontal side of the triangle as x minus 9. But the distance from the general point to the directrix was more challenging. They reasoned that the distance from the point x, y all the way to the x-axis is y units. Then they subtracted 13 units. This gave them a distance of y minus 13. But this distance is shorter than the distance from the general point to the directrix. To get to the directrix, they had to add p units back in. So the distance from the point x, y to the directrix is y minus 13 plus p. Next, Sasha and Keoni find the length of the other sides of the right triangle.
So for this distance, from here to here, it will be y minus 13 minus p.
Because you have to take off that chunk to the... Or wait, no.
Because here's our 13.
Yeah.
So we're subtracting. And then we have to
that is our
subtract
vertex
more too.
somewhere right there, right? Like
Yeah,
right there?
it's like right here.
Okay. So yeah, so minus that 13 from there to there, and then minus that p right there. Yeah.
So we have all of our sides.
Oh, because this one
that's-
is the same as that one.
Yeah.
So it's just not really space, so we're going to go like that.
Sasha and Keoni reasoned that the definition of a parabola tells them that the length of the hypotenuse of their right triangle will be the same as the distance from the point x, y to the directrix, which is y minus 13 plus p. They determined the length of the vertical side of the right triangle by first finding the distance all the way to the x-axis, which is y units, and removing the distance from the x-axis to the vertex. They were left with a segment that is y minus 13 units long. But that's longer than the vertical side of the right triangle. So they removed the distance from the vertex to the focus, which is p units. This means that the length of the vertical side of the right triangle is y minus 13 minus p. Next, Sasha and Keoni substitute the lengths of the three sides of their right triangle into the Pythagorean theorem.
Go ahead and write down the.
Oh. This is going to be wonderful.
This is gonna be amazing.
It's messy, isn't it? And what is making it messy?
That extra number, because we're used to just doing two numbers, and now there's three.
Yeah.
Exactly. Now, before we talk about how to handle that, Keoni, can you get the squared term in there to just finish off your?
My bad.
So, in algebra, have you ever done multiplying trinomials?
It's long.
It's long. We're going to make it a little easier.
Yay.
You had no trouble when it was just two terms. That's called a binomial. Take a look at your two messy terms, the y minus 13 minus p and the y minus 13 plus p. Do you notice anything?
The y minus 13.
These two signs are different.
Those two signs are different.
But the rest of it is the same.
Yeah. So I'm going to help you here a little bit. Can you pick out another color?
Yeah.
And put parentheses around the y minus 13? Yeah.
Okay.
And then around the other one. I'm going to have you basically turn this trinomial into a binomial. So when you multiply it out, I want you to treat that y minus 13 as a term.
Okay.
Okay.
So we would have y minus 13 squared.
So it'll be the y minus 13. That's a 3. 13 times the p now, right? So times negative p. And this is adding together, right? Right? Because it's going to be that one and that one to that one and that one. But then now it's going to be the negative p times y minus 13. And
You want to kind of talk through what you've done so far?
Okay, so we took this one, so we spread them out, and so we had this one, and we multiplied it by that one, and then we multiplied it by that,
Mm-hmm.
and then we took the p, right?
And then we took the p and multiplied it by that.
the other
and
p.
Then, yeah.
Okay.
And
then
the negative p times negative p was what?
So it was negative p times negative p, which is just p squared.
And between those different terms, what sign do you have?
Plus.
Can you combine the two middle terms?
2 times everything.
Yeah, there you go.
So okay. Times, like that?
And you can pull that negative sign out if you want to.
Oh, okay.
So just leave the p there, and then the sign in front would be negative instead. Do you know what I mean?
Mm-hmm.
Yeah.
Can you write that whole line then? So you have y minus 13 squared.
Yeah.
Oh my gosh, we missed something else.
That's just this.
That's just that.
Holy.
Now you've got the you're doing great. Now you've got the next term. You can leave that.
Yeah, because we like that.
Mm-hmm.
Well, and this one's going to be basically the same thing, just
With
the
the
plus,
positive
right?
p.
Uh-huh.
So it'll be the same one. Just
Can-
would it be positive 2, not negative 2, right?
Can you think that you can write it?
Is it?
equals, can I like write it under over here somewhere?
Okay.
Y minus 13 squared plus 2 y minus 13 times p plus p squared.
Do you agree with that, Sasha?
I do.
Cancel
Cancel,
these.
cancel.
There you go. Can you write what's left over?
So we have negative 2 y minus 13 times p
And then the
plus
x
x minus 9 squared equals 2
2y
y minus 13
p.
p. So we add all this over. And we get x minus 9 squared equals
What can you do now? You're almost there. You want to get y alone?
Okay.
divide both sides by
Like 4p?
4p.
Yeah. Nice.
That sounds familiar now, doesn't
Right?
See, out of all that messiness came something very
yeah,
familiar.
we actually like that one. That looks
So
so
then we
nice.
get x minus 9
Squared
over 4p equals y minus 13.
We know that was a 13.
And now
anywhere.
we add 13 to both sides.
Oh, doesn't that
Oh,
look
wait.
so nice now?
And then we get y equals x minus 9 squared over 4p plus 13.
Sasha and Keoni made a difficult equation simpler by treating y minus 13 like a single number. As a result, they only had to multiply binomials instead of trinomials. Sasha and Keoni combined like terms. And rewrote the rest of the equation. To multiply the terms on the right side of the equation, Sasha and Keoni noticed a pattern. The only difference between these terms and the terms they already multiplied is a sign. They used this pattern to reason that the quantity y minus 13 plus p multiplied by itself would be the same as the product of the quantity y minus 13 minus p multiplied by itself, except for the sign of the middle term. Then Sasha and Keoni subtracted identical terms from each side of the equation, which had the effect of canceling or removing those terms. To get the two terms containing y together, Sasha and Keoni added 2 times the quantity y minus 13 times p to each side of the equation. To get y alone, they divided both sides of the equation by 4p. Finally, they added 13 to both sides of the equation. So the equation for a parabola with vertex at 9, 13 and an unknown p-value is y equals the quantity x minus 9 squared divided by 4 times p plus 13.